Hey everybody, amprepairguy.com, also harbachellectronics.com. Please like, share, and subscribe. So I'm waiting on parts for a few Ameritron amps, and I have more in boxes. So I wanted to get the last two things set on this, and I just have to order some cabling. I can start the external cabling, and then I can start the preliminary testing before I make it produce full RF output. Just have to check every little thing first. That's how you're supposed to do it, so don't want any bangs or pops or any damaged components. I always quadruple check everything, always. So, always. Okay, so I'm going to go over everything, show you what I did. So this is an output rotary switch from a Kenwood TL922. The amp's rated for, I think, 1200 watts output. So this will easily handle the 600 or so to get it to full output. The continuous, this box is rated for continuous duty at that amount. So this is a Pi network set up same way as it is in the 922. So I have all the padding caps on the C1 and C2 side. You see down there? I had some, and I had to buy some. I have mica caps. I already had those. So this is a 160 through 15 meter box. I don't really care about 10. The output rotary switch was free. I already had it, so I was limited by that. I mean, technically I could add 10 if I really wanted to, but I have another RF deck, same cabinet, that already has 10. It'll cover 10 and 12. So I have the screw in here to stop it from going to the extra position, but I could also always enable that. But again, I don't really care about 10. But if I wanted to add it someday, I could just use a relay instead. So, okay, so you can see all that. So I have the right angle drives. These are the output. That's the load side. That's the tune side, C1, C2 for the output network. Used right angle drives with universal joints with the whole sprocket and chain setup. So remember, I'll show you the front panel in a sec, but I have like 3 or 4 sets of these meters. I think 4 sets. They're 100 microamp, full scale, and I had to use this board to use those, and I wanted to reuse the old panel because I want to use the old panel. Since I want to use the old panel and wanted to make everything line up, I had to do the chain drive stuff. When I make another one of these someday for someone, it'll be 80 through 10, and I'm not going through the right angle stuff with chain drives and all that. I won't need twice the inductance for the output network or as much for the input. It'll just be, there'll be a lot less going on, and I can, just won't have as much stuff, coils mainly and extra caps, eating up so much space. And I'd end up going with, it's limited by this, but I could have, another one I would go with caps with more range, and then I wouldn't need as many patterns. But, okay, so see all that? Everything's soldered nice. So I use the socket. Here are the caps. Again, everything's sized for continuous duty. This is a idea Tom came up with, WHAI. If enough of those ferrite beads in here to get down on 160. I forget what size wire this is, but it's fine stranded, very flexible. Rated for the full current of the filament, so I don't have any heating. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9 cores, and this is set up so I can take a filament voltage reading from the back. These 2 connections back here, my probes would stick right in, my fluke probes. It also goes over to the protection board, and I can see it on the front panel. So RJ1A for the output switching. There's Teflon coax. RJ1A for the bias switching, so super fast. Got the potentiometers for the grid and plate overload settings. Not really needed, but again, I already had the board. And if I didn't have to get everything to work with the board and reuse stuff in the bottom, I'd be done by now. But this was actually a challenge, and I'm sure I might have an issue there or whatever, but I'll figure that out. But it's going to be worth it. Okay, So there is a power meter on the front. At some point I might, it's 100 microamp also, I might use my 100 microamp line section for that. And use it. I'm not sure yet. I'm not worried about that right now. So I just want to get this thing going. So use the 100 amp supercon connectors. This is the pressure interlock fitting. Basically there's going to be a tube that goes from this one to the one in the bottom cabinet, which I'll show you. So once the pressure comes up, and I'll explain all that, I'll show all of it, the interlock will engage and then it fires a relay. Okay, so SIP16 DIN for the output, SO239 for the input. Here are the adjustments. Here's the hole for the conduit that carries the B positive and B negative. Output, exhaust, output, exhaust. I can put it, this is stock, I can put a tube on it and, you know, vent it outside or whatever. I don't want to go through the top. I'm going to see how it runs temperature wise. You know, that chimney was already in it. I started this years and years and years ago. So, you know, if I were to do it again, I'd use one of those Teflon ones from Tony down in New Jersey, like I did in the other RF deck I have, and the 6-meter one. And then I might have just gone up out the top. The problem is this is going in a cabinet, then I'd have to put a cover on that, and then stuff can, like dust and stuff, can fall down in there, and you just don't want that. Okay, so yes, I high potted these. These handle, I forget what they high potted at, but they handle way more voltage than I'll ever have here. It's 50 ohms, so it's 50 to 50, so not much voltage. Okay, so I think that covers the bottom. So you have the Amphenol plug. This is doing nothing. The Amphenol plug, and I have a shielded cable that connects this to the bottom one, carries various things to the board, and a low voltage or whatever, you know, the key line, all that stuff. Okay, so I'm going to flip this over and I'll show you the top. See you soon. Stay tuned. So before I flip it over, I almost forgot, I want to show you this. So this thing is just so well built, this cabinet. That's why one of the reasons why I like using these cabinets. It's folded over in the front, so it attaches to the front panel. These holes will be blocked. I'll show you how in a second. Countersunk screws. I enlarged the opening so it matches the one in the plate that I'll show you in a second. And yeah, so the blower outlet will have no obstruction whatsoever, so there will be no back pressure created, which can cause cavitation of the impeller. And the blower is rated for the max CFM and pressure. Actually, it will allow the tube to exceed the amount of anode dissipation, but I don't plan on running it like that. But you can never have enough cooling. If you have enough to blow the tube out of the socket, then you have too much, but I have yet to see that. Okay, so I will see you guys soon. Okay, so this cover goes on the bottom cabinet, which I'll show you after I show you inside the RF deck. This is like a soft neoprene foam, very thin. You see the EBM PAPS blower has a plug on it. Those wanting to see the model number, there it is. Awesome blowers, not cheap nowadays. It's basically the this has a lip on it also. It's basically the RF deck's going to slide over this, but I'll show you that when it's in the cabinet, which you will see at the end of the video. Okay, so this covers those holes in the top, or those holes that don't screw into anything, so that'll seal those up right here. And I'll flip the RF deck over and show you the inside. Stay tuned. Okay, so here's the inside of the RF deck. Jim VE7 RF made me this plate choke. It's ferrite loaded. Let's see how that goes. The bypass caps, a couple smaller 7.5 kV doorknobs in series, plus the large ceramic disc caps. So remember that cable is going to come through here, and the B positive will connect the base to that stud, and the B negative will connect to this stud. You have two RJ2Bs in parallel, short strap going over to the 7/16 DIN on the output side, close to the front, to the rear panel. That's SFT, Sugar Frank Thomas, or I should say Sugar Papa Tango. Coax right there, Teflon dielectric, the blue stuff, and then the Teflon coax for the coax going back to RJ1A for the feed through when it's unkeyed. The multiple coils here. Got the modified 40 amp rotary switch contacts and the center part's the stator, I believe. I forget. I'm sure someone will correct me. So now it's an 80 amp. Got the C1, the C2. And RF is not going through these bolts. It's just clamping the copper down to the flange on the capacitor. Everything's soldered. These are silver plated brass screws. I have the copper, like a copper L bracket on one side and then another one on the other side, connected to the strap, each strap. Everything's soldered. I'm a fanatic about connections. Okay, so the coils are on standoffs, all of them. This one gives it stability over here. I go through strap that's wrapped around with a brass screw through it with a nut, machine screw, and then that is soldered to the piece of copper. And the output coax is connected to a piece of copper, and that's also soldered. Got the safety choke. I believe it's 69.3, almost 70 microhenries. And it's soldered to a tab over here. Connected to the chassis, plenty of clearance. Hard to see, but plenty of clearance. And that's a spark gap. It's pretty much set, but I can fine tune it with a feeler gauge, like an automotive feeler gauge. I just loosen the nut up and then adjust the screw and then retighten the nut. So two nuts. Okay, so same over here on the plate side. Got the plate blocking capacitors, 2, 3, 4, 5 of them in parallel, 200 puff each. See the socket. Some will say, oh, it's got tarnish, who cares? I don't care. This is G10 material, this is Teflon, fits like a glove. So this is the B positive anode connection, these clips, so it'll just clip onto one of the fins. And then I'll use a hose clamp around the perimeter of the tube. This is soldered to the strap right here. So that's about it for the output network. And again, this has a nice cover. It's around here somewhere. Right here, you can see it has a bent front lip and down like this. This one-handed. So I have a little over here. I have not done this yet. This attaches right here. The old cabinet had a divider wall. And it had like there was a divider wall here and divider wall here, and there's like the divider wall had a lip, and it allowed that cover to connect to that lip. So I don't know where it went. I gotta find it. I have another one of these decks I might have to take apart, and then I'll cut that piece, and it has the press and nuts, and then I can, you know, just these will attach to each other, and I'll cover these holes up. So this is the better of the two, because see how you can put the screws in and just loosen them and then just slide it off instead of having to take all of the screws out. That is a pain. Okay, so I'm going to put this cover on, and then I will show you the bottom. Actually, I'm going to show you the front panel first. See, everything's lined up. So I have turns counters. I haven't labeled. Yes, everything's getting labeled. These backing plates are going to come out. Actually, I'm going to take them out of a spare set of meters. I'm going to send them to Ram Meter, and they're going to re-silk screen them so they say exactly what I want when the high voltage meter has been doubled, which is in the multimeter, and the other ones will be rescaled, like I said. And this is the protection overload reset, standby operate, and I have a notebook with all the settings for the different bands for turns counters for the C1 and C2, and I wrote down how to realign everything if the chain were to pop off. Here are the input circuit settings. Here's the input circuit band switch, output band switch, and so I can turn each one and then lock it in place. And I have reduction drive, so I can really fine tune it really well. It's really good. So I have to plug that hole. I thought about putting an indicator or something here. I just used appliance paint and actually came out really nice. So I have plastic washers behind the screws so they don't gouge the paint. And again, I have like 4 sets of these meters, and I have a lot of these Raytheon turns, spinner type knobs, and one of these 2 knobs to match, a little pointer. So I can go from band to band pretty quick. Progressively shorting rotary switch is the way to go. Just click, band, set these real quick, versus having to crank in a roller inductor. There's so many downsides to a roller inductor. Notice how this has this channel for a slider. You're going to see what that does at the end of the video. So I'm going to put the screws in this, and I will some of the screws to protect everything, and I'll see you guys soon. Stay tuned. Okay, so here's the bottom. A lot going on down here, that's for sure. This is the area that'll get a lot of testing. Confident that I wired everything right, but I'm not perfect. I make mistakes. So first off, these caps are provided to me by Jim V7RF. Right now I have a line issue. Voltage, as you saw with the 6 meter amp, I just have a really long service drop over 200 feet, so the line voltage is really sag here. I'm going to get that fixed. I'm going to try to get it fixed before I go to do the test video on this. These were free. I give Jim stuff, he hooks me up. So if I could fit oil caps, I mean the oil caps like low ESR ones that have a nice high ripple current, they're huge. They wouldn't fit in here, period. So these are great. These will last my lifetime and some. I think the ripple current rating's like over 9 amps with all of them. I mean, they'll just, I won't have any problems. They'll get cooled. They have a diode across each one, a resistor, so if one of the rectifier strings shorted, they'll protect them from raw AC. I also have a diode in series with one of the plate secondaries to protect the transformer. Just really spared no extra thing, extra protection features on this thing. Yes, used a piece of wood. What to do? I've done that before. People made comments. These caps are not touching the wood. This will never be in a humid environment ever. They're secured by these plastic nylon clamps, and there's a gap below each one. They're not touching each other. The screws do not touch the metal. I will never have a problem. Low voltage supplies to run, contactors, relays, protection board, all that stuff. Everything in the amplifier runs on 240, 2 separate circuits, one for the plate supply, one for everything else. So if I lost the plate breaker for whatever reason, I would not lose the blower and everything else. There's a blower delay off timer. That's what this cap's for. That's the motor on cap for the blower. Here's the connection for the blower. This assembly can come out. Unplug these 2 plugs, 4 screws, comes right out. 250 amp super ground connectors. I have interlock relays all over. The pressure interlock right there, which fires a relay because this isn't rated for much current. You have the filament transformer, variac to fine-tune the filament primary. These are 100 amp supercon connectors, reverse connected diodes, groups of 3 per side, high voltage fuse, series of the B positive, 50 ohm glitch assembly, rated for the total continuous output of the amplifier. Remember, the blower sitting down here, and it's going to draw a ton of air through this filtered opening in the front, so everything's going to get cooled off really well. So I had to make some brackets to get the filament transformer to mount down to the stock bolt nut. There were like permanent nuts in these channel pieces for the plate transformer that used to be here, and this thing was stock. It was like a 4 kVA plate transformer, so that is in there nice and secure. I have the rectifier assemblies, I believe made by Peter Dahl. They are not touching wood. They are isolated with plastic standoffs. I have studs coming through. That is not going anywhere. So I love mercury contactors. Someone made a comment about them. They will not blow up. Just have to be careful with mercury contactors because they can engage if you were to jolt this. But I would never have the covers off without the breaker off. Okay, so proper size wiring, all Teflon wiring for everything I added. 2 number 4s per. I'm only switching one side of the plate primary, so 2 number 4s in parallel. So won't have any voltage drop there. You got the soft start board, which I had to modify, and blower run section on there for the delay off. Some more interlocks if this assembly is removed, shuts it down. I have a thermal switch, so if the intake temp were to rise above a certain amount, it opens the key line. A voltage meter dropping resistor. Sorry about my fingers here. So, if you want to get a more in-depth description of things, check out the other videos, but just wanted to show an overall in one video because a lot of people don't know there are other videos. So here's the soft key. Radio only sees this, period. That key's everything else. So you got the soft start resistors. I didn't put the fuses in yet. These are the main line fuses for the twist lock, and everything's going to be labeled. That's the filament fuse, low voltage fuse, breakers. One's for the soft start, one's for something else, I forget. Oh, that's a soft start. I think these are for the blower. This indicator is across the last cap in the chain on the B negative side. So it'll tell me if the filter caps are still charged. Still go in there and take precautions with a shorting stick with a resistor in series, and then, then after that, go and short each one. You just don't take any chances. So I want it on the back. I don't want to load the front up with stuff. So I'll put a knob on that for the filament adjust. Should be set and forget. B positive, B negative, GTO wire, and they're in this braided material, and it is grounded in here with a lug. Let's see, that's right down there. This side will be grounded inside the external transformer cabinet, and these connect to studs. I put some heat shrink over it. So there's a I'm sorry, I take that back. I get up early. These are not the B positive and B negative. These are the transformer secondary leads. Sorry about that. I'll show you the B positive and B negative in a second. They connect to this. This is called an Alden connector. Okay, great connectors. Okay, I'll be right back. And this is the pressure interlock barb. So I'll have a tube go from this one to the top one, and this is the keyline RCA. Okay. See you soon. So here's the assembly that carries the B positive and B negative. So, Alden connector. So this goes over that hole and it pushes on the interlock. The stock, so I left it. This is metal conduit underneath this plastic sheathing, and this is what goes up to the RF deck. And you see the two connections. Will connect one to the connects to the base of the plate choke, and this is the one that connects to the stud on the standoff for the B negative. Okay. You can see it is not here, so hey, I will see you soon. Okay, so I'm trying to show you step by step here. You see the blower, it's not connected, but drops down, plenty of clearance. It's over an inch. Okay, so rubber gasket. Filter's not installed yet. Here's the on-off switch. It's a bat style. You gotta pull it out and flip it up. This cabinet has a flange here to put the screws in. Put one here, one there. This will be coming apart again. So you see the sliders. The German Shepherd. There's hair. I have to vacuum. Okay, so I will see you soon. And this isn't painted yet, obviously. Be right back. See, it slid out. Pretty nifty, huh? It's heavy. The bottom part is heavy. Really heavy. Lucky, because I was worried I was going to have add some steel weights in the back. So, it does not tip forward. I'm going to slide it in and I'll be back. See you soon. And that's what it looks like when it's all slid in. Filter installed. Yeah, lots of fur, not hair, I called it hair before, but I vacuum back. Well, anyone that has German Shepherds or ever has had one knows they shed a lot. Okay, so shed. So this is missing the screws to go into the cover, and then bottom cover. Need to get more plastic things, but this is gonna come apart again, maybe even multiple times. Okay, so I'm gonna show you something else. I'm gonna wheel in the transformer cabinet and then also the panels for this. I have tape all over it. Okay, I'll be back. Okay, so I'm back. So this cabinet has panels. There's one side panel. There's the rear panel. It's all vented. Has a hole cut out for the exhaust port, so that'd be covered. Here's the power supply cabinet. See the nice short length. You got the switch. One of these is this, doesn't matter. You have a switch side and then the line AC coming from the breaker. So this switch side goes over here. The other one goes to the other side of the 240 breaker. These two wires will come for the transformer secondary, go through the grommet, and the shield connected to the metal in here via a stud. See the transformers. If you want to see the transformers, that's one. The other one's up top. And look at another video, past video. It's a filter, and yeah. So I'll show you the panel that goes on the front. I'll have to do something about the turns counters because the knobs, I'll make it so they pop off. But this will go on front. You won't even know what it is. That's the nice thing. It will be protected. Unless someone says, oh, that's what it is. You won't even know what it is. I mean, last one, I did one of these years ago where I had the cabinets powder coated. And I made a mistake with that because if you chip powder coating, you can't fix it. So I'll paint it with enamel paint. And probably just bring it somewhere so it looks nice. And you can see, actually, I'll get this off. So, all Teflon wiring. And it has a fan on the top. Pull the air up, out. Reuse this hole that was there. And yes, every single thing is going to be labeled. This breaker is no longer used. It'll be labeled. These are the line fuses for the fan and also the indicator lamp. This will tell me the line's on, but you never assume. You always unplug and check things. Well, if it's unplugged, you definitely won't have voltage there. But you never assume with filter caps, ever, especially that amount. Okay, so I'm going to show you one thing real quick. But this was a lot of work, and parts, if you add the parts up, you're looking at over probably around 10 grand or more. Parts, everything adds up, especially nowadays. So yeah, if I ever had to make one of these, I mean, it'd be 80 through 10, you're looking at over 40,000 bucks. And to be honest, at that point, I'm repairs make more money in the amount of time. This just takes so much time, and that'd be in a new cabinet, socket, new tube, brand new transformers, brand new everything. Vacuum variables would be new old stock, because they're a fortune if you buy them brand new, current stock. But you can see the pressure. So the hose will go from here to here, and the interlock. I'm sorry. Tired. The shielded cable here to here, they're already made. I'll grab one in a sec when I show you the last thing. And the B positive, B negative assembly connects here, and then the cable comes up to here. And then you have the filament leads. These are expensive if you buy them new. It's AC, doesn't matter which way you connect them, but filament here to here. And yeah, so everything came out really nice. Nice. And you put nuts on here. This is part of the cover, internal cover. So I have boxes of these fuse holders, boxes of these fuse holders, boxes of these fuse holders. So just literally hundreds of each one. So I just used what I had. Jim hooked me up with a couple of these. I already had some. These are awesome. I've been using these for over 10 years now, and I see other people using them now too. They're great. They have anywhere, I think, from 25 amp all the way up to 250 amp. Someone said, why don't you use a big Hubble twist lock plug? Oh my god, it'd be huge. And they are big bucks, and it wouldn't fit. So a lot of these parts, like this twist lock plug, eBay. I mean, I just look around for good deals, things I had to buy. I bought these from the hardware store. So 239 came from, I don't know if that one came from Max Gain Systems, but I use Max Gain Systems now for stuff. Like all the parts, I just looked around for good deals. But new stuff. But things like a tube, I already had 2 tubes, I already had the socket, I already had the plate transformers, I already had the filament transformer, filter caps. They're big bucks if you have to buy those new. Vacuum variable caps, I already had those. Air variable caps, I already had those. TL922 band switch had that. Output band switch, I already had that. Metering cabinet. Even cabinets are big bucks. I buy one from Charger, for the top bottom. They're, I don't even know what they are now. Probably over 500 bucks for a set. But great. He's a nice guy down there. But I had a Henry AK Ultra. I'm not even gonna get into these amps, but parted it out. Helped out a lot of people that needed parts to get their amps going. Tape all over everything. I'm packing hardbox kits. So about that. So this is a great cabinet. I was dreading making something. Guy wanted to buy this, but I said absolutely not. I want to keep it. So yeah, metalwork is a big part in making something, but Jim says it all the time. But you can buy cabinets from Tony down, Charger, and you need to have the proper parts and proper RF layout. I mean, there's a lot to it, more than just a cabinet. So he's like, I need to put screws in. There's screws that hold the bottom cabinet in the channel also. Just a very well built frame, rolling cart. This cabinet material, I believe, is 1/8 of an inch thick, just very solid. So I'm going to show you one other thing real quick. I'll be right back. I'm going to wrap this up. So people have made comments about oil caps. Why don't you use an oil cap? Electrolytics suck. If you don't know how to calculate ratings, yeah, either or can suck, because I've seen people where they put electrolytics in and they don't have a high enough ripple current rating, and they blow them up. They just, fail. So these caps in this amp have way more than's needed. They're gonna, I'm not gonna exceed the temperature or any of the ratings. So they're gonna last a long time. I'm sure they'll outlive me. I mean, there are caps in SB200s that still operate, and I'm 44, and those things still, they're SB220s that are, they're built before me, and I still see ones with stock caps. So I don't want to hear that. Okay, so yeah, it's easier to have one oil cap, and yeah, if I could fit the prop oil cap in there, and I had it, I got these for free. For a customer, I'm not going to use as much capacitance, but they're going to have good line voltage, because you don't want the anode voltage going all over the place. You also want a transformer with a really low secondary resistance, which these have. I mean, there are a lot of factors. Yeah, this is way more than I need, but they're free, and I have the proper series glitch resistor. So, but caps are not cheap nowadays. To get those ones that are used in the Henrys, they rate them for like 7.5 or something, but they say to run them at 5, and they're not cheap. So, I have more than 5 kV in here, so what, are you going to use 4 of them, 2 in series with 2 in parallel to get, what, 16 microfarads? Yeah, nah. So, anyway, here's an example of an oil cap, and like I was saying, not all oil caps are the same. You have high energy discharge ones used for like lasers, pulse discharge. Those ones usually end up overheating. They're not rated for a lot of current. This is a genuine broadcast cap. These are awesome caps. I have a few of these. I have other ones. I have a whole closet full. I want to get rid of them. I just don't like dealing with eBay. I have enough going on. So, just to give you an example, this is rated for 28 microfarads. Okay, that would be, that'd be pretty good. If you have good line voltage. This is rated for 12.5 kV, so I like having some headroom. The ones in the multi-band amp, I have a total of, I think, 9 kV worth of headroom. Total voltage. I shouldn't say headroom. So this would have a lot more than that. So, but one rated for 10 kV isn't much smaller. Look how big this is. It's huge. It's my drill. Look. It's huge. So, actually, let me grab something here. Might not know how big the drill is. Here's a 12. What's this? A 16.9 ounce bottle. Okay. It's huge. So, actually, one second here. Hey, sorry about that. Batteries running on fumes here, so I'm going to wrap this up. So this is huge. It wouldn't fit. Okay. Here's the interconnect cable, shielded, like I said. And so that wraps it up. Appreciate you watching. Just to forewarn you, it's going to be a bit before I can get to testing. I have to order the cables, and holidays are coming up. But the next video will be a full-blown power test. I have to get my line voltage situation taken care of too. So I just be honest, might not be till spring. I have an underground service, and I'll have to dig a trench and all that. It's like 160 feet to the road, and goes up a pole across the street, and it's just a nightmare. But thanks for watching, and almost there. Almost. So stay tuned. Please like, share, and subscribe. And this has been a fun project. It's so easy to make a monoband amp. I think about anybody can do that nowadays, especially if you know how to solder and drill holes. But this has been a real test in so many ways. I mean, the chain drives and getting everything to fit in this nice small cabinet, minus the transformers. But if this wasn't a continuous duty rated amp, I mean, it'd be a different story. I could probably, stick a transformer down there, or maybe, I don't know about that, but the external cabinet would have been smaller, a lot smaller, and parts could have been some of them a lot smaller, coils, all that, but if you're going to do it, if you're going to build something like that, you might as well make it continuous duty for AM or digital. I mean, I'm not going to run that. I mean, the thing would stay within the legal limit, but if you're going to build something around a certain tube, why not make a continuous duty cycle, right? And, that tube costs less money than an 8877. Has a way more robust grid. And again, less money than an 8877. I had 2 of the tubes, socket, all the other parts. And I don't expect anyone in the USA to pull the trigger on buying one. It'll be most likely someone outside the United States, just like the 6-meter amp. But I'll remind everybody, here within the United States, we can own, as a licensed operator, you can own whatever size amp you want. You just got to run it within legal limit. And there's nothing wrong with headroom. And people say, that's a lot of money. Look how much an AL1500 cost before they stopped selling them. What was it, like $7 grand? Look what you got. 2,500. You know, if you pushed it, intermittent, legal limit, intermittent, it's over $7 grand with an expensive tube. You know, so some people buy choppers. How much does a chopper cost? How much does a boat cost? How much does a classic car cost? How much you got to spend on insurance, maintenance, all that stuff. Buy an amplifier, you own it, you use it. And then 20 years down the road, maybe you need a tube. But, okay, well, thanks for watching. Please like, share, and subscribe. 73.